Good afternoon, class. This is Monday, June the 8th, 2020, day 43 of Coronachem, period 4 class. I gave you two questions for homework yesterday, 1552 and 1572. Here is the answer to 1552. It shows a reaction in which carbon dioxide and water combine to form glucose and oxygen. Definitely not a spontaneous reaction. This is basically the net equation for photosynthesis. This is what plants do. That's not the reaction obviously that's not the reaction they actually push. It's the net result of all the metabolic steps that take place that grab carbon dioxide out of the air, combine it with water that is sucked from the soil along with the necessary minerals to form glucose, and then the glucose is re-engineered by the plant's enzymes to form lignin and all the other substances you find in wood or the natural products that you find in the sap of the plant. But it all comes from the carbon dioxide in the air. It's a very sobering thought to realize that when you're looking at a tree, what you're looking at is condensed air that has been sucked out in the form of CO2, mind you, which is only present at around 400 parts per million. So the plants steadily suck the CO2 out of the air, and they turn themselves into the tree, and then they form the basis of light. They convert sunlight into physical objects that provide shade and nutrients and building materials. Really a wonderful thing if you think about it. Let's look at the net reaction, which is obviously catalytically made to occur. This actual reaction doesn't take place. I mean, you could take carbon dioxide and water and subject them to heat and pressure, and you might get glucose, but quite the opposite tends to happen. The reaction tends to go the other way. It's an exothermic reaction. But let's look at the equilibrium as it's written. So it's got a delta H of positive 2,816 joules, which means it's as though you put the heat as a reactant. It's an endothermic reaction. Part A asks, how is the equilibrium yield of glucose, C6H12O6, I'm assuming that's what it is, affected by increasing the partial pressure of carbon dioxide? So if you increase the pressure of carbon dioxide, it should shift the reaction that way, so you would get the production of extra oxygen gas. The amount of glucose obviously will get produced, but it's a solid, so it has no effect on the pressure. The solid does not participate in the equilibrium, neither does the liquid. It's these two things that affect the equilibrium, the oxygen presence and the carbon dioxide. So it has no effect. B, increasing temperature increases the partial pressure of oxygen, but has no effect on the glucose, because again it doesn't participate in the equilibrium process. Because it's an endothermic reaction, increasing the temperature is like adding extra reactant, and we'll shift it that way. Removing carbon dioxide will decrease the partial pressure of oxygen, but it also has no effect on the glucose. And then decreasing the pressure, paradoxically, has no effect, because the gases that are involved in the actual equilibrium are present in equimolar amounts. There's 6 moles of CO2 and 6 moles of oxygen, so reducing the general pressure should not have an effect on the equilibrium. E, removing solid glucose will have no effect on the reaction because it's a solid. And then finally F, adding a catalyst will speed the attainment of equilibrium. So if the reaction is not at equilibrium, it will get there more quickly, but it will not affect the position of the equilibrium. Enzymes, that's what they do. They speed up the attainment of equilibrium, but once you're at equilibrium, adding the enzyme has no effect anymore because the reaction is already at equilibrium. Okay, Incidentally, our body can capitalizes on this effect by if you have a certain nutrient that your body needs more of, and there's an enzyme connecting that nutrient to another nutrient, then the reaction will go this way. If you have too much of the other nutrient but not enough of that one, then the reaction will go that way. So your body has all kinds of reactions that way, so that whatever you eat, your body converts it to whatever substance you actually need. Could you imagine if we didn't have the enzymes to convert one type of foodstuff to another substance? We'd be in a fine mess, because we'd have to eat a very strict diet of the absolutely necessary metabolite building blocks that lead to the building up of macromolecules. So you'd be in trouble if you didn't eat an exacting diet. We do have certain things that our body can't make. For example, out of the 21 amino acids our body uses, there's 8 of them that are essential. Your body can't make them from using other substances, so we have to have them in our diet. And those are called essential nutrients. Those are things that we must have because our body can't make them. For instance, our body cannot make vitamin C, so we have to have it in our diet. Rats, on the other hand, have enzymes that can produce vitamin C. So rats can get away with not eating any fruit or anything that contains vitamin C because their body can make the vitamin C that they need anyway. So different species have different propensities. And I would say even within a species there are some variations, so that certain races can tolerate one type of food better than another, or there's other races that can't eat a certain food because it actually makes them sick. So this is actually called epigenetics. It's a very interesting area of study, because epigenetics also has an effect on what kind of drugs you can use. If you use certain drugs, that might be toxic for your particular genetic makeup, so you should avoid them. And then there are other ones that might work very well for you. It's also good to listen to what your body tells you. Okay, the next problem. How easily we digress into peripheral issues, but that's the beauty of chemistry. Every road leads to some interesting new thing, and if you're willing to walk down it, you can have some interesting insights. 1572, at 700 Kelvin, the equilibrium constant for the reaction carbon tetrachloride turning into carbon solid and 2 chlorine molecules is Kp equal to 0.76. A flask is charged with 2 atmospheres of carbon tetrachloride, which then reaches the equilibrium at 700 Kelvin. What fraction of the carbon tet is converted into carbon and chlorine? What are the partial pressures of carbon tet and chlorine at equilibrium? You know that carbon tetrachloride used to be used as a fire extinguishing liquid. You can throw it on a fire, the fire will go out. But they stopped using it for that purpose because it produces toxic fumes. They even used to put a similar compound, chloroform, which is carbon tetrachloride missing 1 chlorine and replaced by hydrogen. And chloroform has a very sweet taste. They used to put it in toothpaste to make the toothpaste taste sweet. So kids would want to brush their teeth, but then they found out chloroform is also toxic to the liver, so they stopped using that. There are many things that have happened like that in the past, and I'll give you a little news flash. It's still happening, it's just we don't know some of them. 1572. Okay, so let's start by showing the reaction. And what we get is solid carbon and 2 chlorine molecules as products. We're told the Kp equals 0.76 and at 700 Kelvin. That's important because if you change the temperature, you're going to change the equilibrium. We're also told that it starts off with a pressure of 2 atmospheres, and we could draw an ice table. And we're starting off with 2. Let's just write it over here. 2 atmospheres. And a certain amount of it X reacts. We don't know what it is. Let's call it X. And that equilibrium is going to be 2.0 minus X. And carbon is a solid, so it doesn't participate. The only thing that does participate is the chlorine gas, but you'll notice that the stoichiometry is 1 to 2. So if you lose x over here, you're going to gain 2x over there. So it'll be plus 2x, and you're going to get 2x at equilibrium. So when you write your equilibrium expression, Kp is equal to the partial pressure of products, chlorine gas, I should put the P inside the bracket, I guess, to the power of 2, over the pressure of carbon tetrachloride in the gas phase, not raised to any power, and that's going to be represented by 2x squared over 2 minus x, and all of that has to equal 0.76. So when you expand that, you get a trinomial. I'll save you some space. I'll I'll go straight to the trinomial. You get 4x squared plus 0.76x minus 1.52 is your trinomial. You got to solve for x. I did it by using the quadratic formula. X equals minus b plus minus the square root of b squared minus 4ac all over 2a. And I solved it that way, but let's do it with a calculator just to double check my work. So in your calculator, you have a function. Let's see if you can see it with the phone. Yeah, okay, you can see it. So on this phone, I'm going to press mode equation, which is number 4, and then I'm going to put quadratic, which is number 2, and then you get those 3 numbers popping up. Okay, you're going to enter for the first one A, you're going to put a 4. For the second one, you're going to put 0.76, and for the third one, you're going to put negative 1.52. That's the value for C. So I'll see if I can do that. So 4, enter, 0.76, enter, and negative 1.52. If you don't put negative, you're going to get the wrong answer. It's got to be entered exactly. There you go. So you get 2 answers. One of them is positive, one of them is negative. So you're going to obviously you're going to discard the negative answer. You can't get a negative concentration. So your answer is 5.28 or 0.528. That's the value of x, which is the correct answer.
And incidentally, it is the same as what I put here.
So let's write that down. 0.528 718 6866. That's the value of x, and it's being subtracted from 2. They're asking, what are they asking you?
Forgot to check that. What fraction of the CCl4 is converted? Haha. And what are the partial pressures?
Did I even answer B? I did on the next page. Okay, so I'm going to erase. So because x is equal to 0.528, I've discarded the other value, you're going to get 0.528, etc., over 2 times 100 gives you 26.4% of it is used.
Is that what I'm saying? What fraction is converted?
Yeah, 26.4% of this stuff is converted to carbon and chlorine gas. And then part B, what are the partial pressures? So the partial pressure of carbon tetrachloride is going to be equal to 2 minus the 0.528, etc. I'm not going to write the whole number. And after sig figs, you get an answer of 1.47 atmospheres. And part 2, which is the partial pressure of chlorine gas, is going to be 2 times x, or 2 times 0.528, etc., which gives you, after sig figs, 1.06 atmospheres pressure. So there's your answer. I'd like you to try another one like it tonight. Do 73 and 74 tonight. That's going to be your homework. Getting close to the end of the year. Once I finish this chapter, I think I'm going to do the organic chemistry, because you do have a lot of organic chemistry in university. So I'll start that chapter, and then if at the end of the year we have any time left, I'll throw in a couple lessons that could be sort of off the grid as you wish, or as it were, meaning that you might find it useful in university, but I'm not going to grade you on it because it's not really strictly speaking on the curriculum. So we'll do that. Marks have to be in by June 22nd. Here's the deal. Some of you have been a little bit remiss in handing in work. I'm not really out to give you a mark lower than what you had March 13th. So let's work with that premise. I am, though, allowed to say that your work is not complete. If you have not interacted with me in any appreciable manner, I am not going to put my reputation on saying you acquired a credit by working with me, because then you're going to go to university and fail all your courses. It's going to make the school look bad. It's going to make me look bad. So the next little while, I'm going to give you the last couple tests that are going to count for your course content. It's supposed to be around 30%. It doesn't have to be, though. If you impress me with the results that you produce, I could make it 100% on what you turn in this next couple of weeks. So impress me. Wake up, those of you who haven't been participating, and make an effort. Show me that you've learned something, and I'll reflect it in your marks. Okay? So I'll see you tomorrow. Your homework then is 73 and 74. Okay? We'll do those tomorrow, and then we'll talk about doing a mock test.